Now we are working on Chapter 3, Problem 21. A ladder 25 feet long is leaning against the wall of a house. The base of the ladder is pulled away from the wall at a rate of 2 feet per second. A. How fast is the top of the ladder moving down the wall when the base is 7 feet, 15 feet, and 24 feet?
So, since there are many things that we have to solve for in this part of A, we're just going to solve for 7 feet for the first half. So, the first step, of course, is to sketch. So, step 1 is to sketch. So, reading this, they say that we have a ladder. So, we have a nice looking ladder here. And this is going to be our ladder. And we have a wall of a house. So here's our house. We got this window. This is a nice little wall. Then we also have a base, which we can call the grass. So here's our base. All right. So what we do know is that the ladder is moving down the wall when the base is 7 feet, and that's what we're solving for. So this right here is 7 feet. From here to here would be 7 feet. We also know that the rate that the ladder is being pulled away from the wall is 2 feet per second. So this right here is being pulled away is 2 feet per second. We also know, so this is going to be in purple, and this will also be in purple. We also know that the ladder is 25 feet long. So this is 25 feet. So we have, in a triangle, we always have 3 variables. You have your y, x, and your z. We have our z, so this is our z. And we have our x. Our 7 feet is our x. So we need to figure out what y is. So what we're going to do is we're going to use an equation. So this is where step 2 kind of comes in here. So step 2. So since this is a triangle, we know our equation to be x squared plus y squared equals z squared. Or c squared, some people use c, we use z. Alright, so we know what x is, so we're just going to write that down. We know our x equals 7 feet. And we also know the rate of change of the ladder from how far it's being pulled. So that will be dx dt, which stands for rate of change of the ladder per time, which is 2 feet per second. Alright, we know what our z is, so I'm going to label that, which is 25 feet. And we technically know what our dz dt is, but I'll discuss that after we figure out what our y is. So what we're looking for now is our y, which is going to have to be solved by plugging in our x here and our z here to determine what our y is. So we'll do that over here a little bit. and I'm going to say that 7 squared plus y squared equals z squared. So, well, z squared is 25, so we're going to put 25 squared. And what I did here is I plugged in the x, which is 7, and I plugged in the z, which is 25, and I squared them. And that will give me y squared equals 625 minus 49. So I said, I did this squared is 625. This squared is 49, but I have to get on the other side, so I subtracted it already. And that will give me 576, my bad, 576 y squared. And I need to get y by itself, so I'm going to take the square root of both sides. And that will give me y equals 24. So now I know what my y is, and y is 24 feet. Based off of the question, they want to know how fast is the top of the ladder moving downward, so they want to know this right here. The question is, how fast is this moving downwards? So that means we are looking for our dy dt. Since we are looking for our dy dt, that means we have to know what our dz dt is. So dz dt is going to be 0, and the reason for dz dt being 0 is because the ladder will never change its length at any time. So we have finally finished step 2, and it's now time to move on to step 3. And step 3 is always a little bit more complicated, but it's not that bad. So when we derive our equation, we're going to take this equation right here and find the derivative of it. So we're going to say x squared plus y squared equals z squared. We're going to take the derivative of both sides, so we're going to say d dt of x squared plus y squared equals d squared times d dt. And with this, we have to do chain rule for each one individually. So we end up with 2x dx dt plus 2y dy dt equals 2z dz dt. And the reason for this is we take the 2 and we put it in the front, and that's the outside, and we'll subtract it by 1 and we get 1, and so we keep the inside, and then we take the derivative of the inside, which is dx dt. So now we're on to step 4. Which is our plug and chug. This is always the easy step. This is the step that shouldn't give anybody the most problems. So we know that this is going to stay the same, so we're going to put 2. We know that all our 2's are going to stay the same, so I'm just going to write 2 here and 2 there. So since all the variables for x are in purple, I'm just going to circle them individually so we know we're timesing them together, but they all are in purple. So we're going to say that our x is 7, so we're going to times this by 7 feet. And we're going to say our dx dt is 2 feet per second. So I'm just going to give it a little bit more space so I have room to put everything I need to put in here. So I'm going to put this 2 back on there. And We wrote everything that we know for y in green, and we only really know what y is. We don't know the dy dt, that is what we're looking for, so I'm just going to highlight that one. And that is 24 feet. And I'm going to have the dy dt. Now, we're going to plug in what we know for z. And z happens to be 25 feet. And we also know that our dz dt is 0. So we know what this is, and we know what this is. And this happens to be in our ground. So this will be 25 feet times 0 feet per second. All right, so now we're going to multiply out a little bit to kind of help us out. So 2 times 2 is 4. 4 times 7 is 28. So we're going to have 28 feet squared per second. The reason it is feet squared is because I have a feet here and I have a feet here, which makes feet squared. Then we're going to have our y, and that's 2 times 24, which is 48 feet. And then we'll have dy dt equals, and no matter what we multiply it together, we're going to get 0 because we have a 0 at the very end anyway, so the answer is 0 here. Now, we just solved for what we need, which is dy dt. So the first thing we're going to do is subtract this over to the other side. And I'm going to say that my 48 feet times dy dt equals negative 28 feet squared per second. Now I'm going to divide by my feet to the other side, and I get dy dt equals negative 28 feet squared per second divided by our 48 feet. And the final answer is negative 7 over 12 feet per second. So I'm just going to change this up so it looks a little bit more recognizable. So negative 7 feet per second. The reason the squared went away is because we're dividing by another foot, so it takes away the squared, and this is your final answer.